Maybe I'll share the recording with rest. So I am sharing my screen, and today we are going to look at a second classification model before we can go back to regression. And that model is the K nearest neighbor model. Okay, so I'll explain how the model works and how we can use it. So let me create a new notebook here called knn.ipynb. And this will be classification using KNN. Okay. Let's go back to our notes. So KNN. So K nearest neighbor is a supervised learning machine learning model that is mainly dependent on the distance between what we are trying to predict and the features that the data has already learned from. So the basic idea behind KNN algorithms is to find the K number of points in the training dataset that are closest to the point we want to classify or predict. So if we have a look at this diagram that we have here, so this image that we have here, we have two circles. So the broken line one and the full circle, so which is not broken. So here you can see we have this green point over here, and we have the blue and the red points. And when we are fitting a KNN model, our target will be to predict this green point over here. So if we were to focus on this smaller circle here, and if we were to predict the color of this green or the shape of this green item that we have over here, then we would be forced to predict it as a red triangle, because here you can see if we check the number of red triangles in this smaller circle and compare them with the number of the blue squares that we have in here, the reds are many as compared to the blues. So we have only two reds and one blue. So which means that for this smaller circle, we will predict this green item as red. So if we extend this to this larger broken circle, so you can see we have three green boxes, and down here we have two red boxes. So if we were to predict this green item over here, we will predict it as a blue square, because you can see the blue squares are many here as compared to the red items here. So that's basically how KNN works. So it uses the basic idea behind KNN algorithm is to find the K number of points in the training dataset that are closest to the point we want to satisfy or predict, and the majority wins. So here today we can use the iris dataset to do the predictions, and we will visualize these predictions so that you can see how KNN works. So let's import our libraries. And I will start by importing pandas as PD. Then we are going to import numpy as np. And then we are going to have matplotlib. Then lastly we are going to have cbon. Then we are going to have import warnings. Then we are going to ignore all the warnings. Okay. Then the next thing we are going to do is we are going to import. Yes.
Joseph,
Yes.
kindly zoom in.
Okay, let me zoom in. So hope that's okay.
Sure.
Okay. The next thing we are going to do is we are going to import the iris dataset. So we are going to use the sklearn dataset built-in datasets to do this. So we are going to have from sklearn.dataset import load iris. Then we are going to have iris being equal to load underscore iris. So this will load the iris dataset for us. Then the next thing we can do is we can check what is in iris. Okay. So you can see for iris, it has a few, it's like a list here. So it's a dictionary. So this dictionary has the values for the data. Then we also have the target, which is part of the data. And we have the feature names here in a list. And we have the dataset description. So we can extract basically what we need from this data. So we can have iris.df being equal to pd.dataframe, then iris.data. So instead of us having iris.data, I can change this to iris, then I can select the data key. Then for feature names, I can have iris, then feature names being our column names. Then we can have iris df target being equals to that, because you saw that the target variable was in a different column. Then we can have iris df dot head to see if we have the correct thing. So everything is running. So this is the code we are using. So if we use iris and let's say iris, we say that iris should be equals to iris dot load iris. So to access the data, we just have to type in iris dot data. So that gives you an array with all the data. So if you want to know the target column, so you just type in iris.target. So you get a column here with the target. Then here you can get also the feature names by typing in iris.feature names. So feature names here we have sepal length, you have sepal width, you have petal length, and you have petal width. Okay, so what else can you get? So you can get the description. So this is the description of the data. And what else? What else do we have? So maybe I can type in iris.keys to see what we have. So we have the, okay, so again we can get the target names. So iris.target names. And we have the setosa, versicolor, and the virginica colors. So this basically means that our target column has three variables. Okay, so what we are going to do next is create something like a scatter plot.
Joseph,
Yes.
just before you continue maybe to the task for today,
Yeah.
does this apply to all the datasets, or it only applies to the iris dataset
Okay, in terms of,
in terms of checking the targets and checking the features? That's why actually I'm kind of like, okay, what about this? Because in this case we can check what you are trying to look for or
yeah,
predict, and in this case we are able to check again on what you're going to use to come up with the prediction, so, or the features, let me say.
yeah.
So if does it apply to the other data sets? But and in case it applies, does it is it a way, is there a way that we can also use the same functions for the other ones? And if there is that
No,
way, yes, yes.
I don't think it applies, because what we are using is we are using sklearn datasets. So inside sklearn, so we have example datasets. So for these datasets that are in here, they've already specified what the features are and what the targets are. so you don't have to like come up with them. So yeah, so for the other datasets that you will be working with, you'll have to define your features and targets by yourself, not unless you are working with inbuilt sklearn datasets.
Okay, I get your, but again, we are also new in this case. In this,
Yeah,
so when we start getting new things, we also like, what is happening? You
yeah,
understand?
yeah.
Maybe sometimes you actually need to
Yeah, I
sometimes
need to
just clarify
clarify.
them before we go through them because we get confused at some moments.
It's okay, but you feel free to ask any questions
Okay,
if you get confused anyway. Okay.
okay.
Yeah, so let's proceed. So we will do some EDA here. And for EDA, the first thing I'm going to do is create a scatter plot. So here we can pick two items. So for example, the sepal length and the sepal width. So how are they relating? This is the pair plot. I believe the pair plot will create all the scatter plots we need, and we will have the hue based on the target column. So I guess using a pair plot at times is good because you'll eliminate the need to like have to do all the EDA stuff on your own. So here you can see, for example, here we have a scatter plot between, so let's have a look at these last scatter plot here. So we have a scatter plot between petal width and sepal length. So here you can see, so in a way, they are, I don't know if this is positively correlated. So let's create a correlation heat map. So we are going to have SNS DF iris. Then I'm going to, it's not a must, I exclude that column, and we can have that. So you can see, for example, the sepal length, the petal width and the sepal length are positively correlated. So which is being shown here. So anytime the petal length size increases, then the sepal length size also increases. So things like that. So you can explore these correlation heat map here and see what happens. So for example, for sepal width and petal width, so you can see they are negatively correlated, and we can clearly see these on the on the scatter plot, because you can see anytime the petal length is increasing, the sepal width is not like changing in any way, and at times it's reducing in size rather than increasing in size. So this one is also positively correlated. So petal length versus petal width. You can see here petal width, then petal length 0.96 correlation. So which means that these values are highly correlated. So this is dependent on this. Petal length is dependent on petal width. So we'll pick one of the two columns. So maybe we will create a scatter plot for petal and petal width, so that we can use this to monitor our model and see if it's giving us the results that we need. So we will have plt.scatter, then we will select the two columns we need. So the first column is the petal length in centimeters column, the second column is the petal width in centimeters column, then the colors will be based on the target column. Then we can run this. So here you can see we have three colors. So we have these black color here, we have these red color here, and we have these. Okay, so let me change one thing up here. So I'll eliminate these white grid, then I'll have something like sns.set instead. Then let me change the color mapping for some of these plots. Yeah, so that's okay. And also that's okay. So the colors are consistent. So today I won't split the data into training and test set. So we will just go ahead and fit our model. So we are going to import the k-means model, and already we know our target column is there. So this is the target column and we have our features. So first of all, I'm going to create my X. So X should be equals to iris dot drop, then I drop the target column. Then our Y should be equals to iris, then we get the target column. So that's what we have. Then next I'll import the KNN model, which is our classifier model. So we will have from sklearn dot neighbors import k neighbors classifier. So what you have to note here is k is capital K, then n is capital N, then here we have C, which is capital C. Then we are going to instantiate the model. So we are going to have KNN being equal to k neighbors classifier. Then we specify the number of neighbors. So here, the number of neighbors. So let me add a comment here. Number of neighbors is the hyperparameter k. So what do we mean with that? So it's the number of it is the k number of points we are trying to look at in the data set. So how many red? So if you look at this plot that we have here, so how many green or yellow members are close to the point we are trying to predict? So that's what the k stands for, or this number of neighbors stands for. So for example, I can use 3 maybe. And what we will do is we can fit the model, then we can predict. So we will have our ypred being equal to knn dot predict. Then the last thing we can do is we can score the model, and we can just get the accuracy score. So we will just have knn dot score, then we pass in our x and y. Then I can run that. So you can see our model is 96% accurate. But what if we change this value to 6? So if we change that value to 6, we get a model that is 97% accurate. What if we change this value to 19? So if we change it to 19, we get a model that is 98% accurate. But let's stick to 6 and 3. So let us stick to 6 first. Then I'll explain how we can get the best number of neighbors here. So once we get the score of our model, you can see it's 97% accurate, and we can confirm this using the classification report. So if we print the classification report, you see here on the part where we have the accuracy, we are getting the 0.97% accuracy. So which means that our model is 97% accurate. And here you can see this model is taking into consideration all the 3 targets that we have. Not unlike yesterday, where the model was taking into consideration only 2 of the target variables that we had. Okay. So we have a precision score of 1 for all, precision F1 score and recall of 1 for the class 0, and 0.96 for the other 2 classes. Okay, so we now have that. So what I'll do is I can plot a scatter plot. Now using the predicted values. So here we will have plt.scatter. So it's the same thing here. So what I want to see is will the scatter plot be similar to what we have up here, or will it have a close resemblance to what we have? So here you can see I'm using the C. The color will be based on the Y-pred. So here the color was based on the target column, so what we originally had. But here the color is based on what we've predicted. And if we run this, you can see the results are almost similar. So let me save this. So for this class that is down here, everything is 100% accurate. So this class that is down here, everything is 100% accurate. But for these two other classes up here, where for example, we have this yellow point. So let's confirm if that yellow point is there. So you can see that yellow point has been converted to be a, so let me say this is blue. So it has been converted to be a blue class because these values that we have over here are really close to each other. And that's the reason as to why we are having the 97% accuracy, because we can't 100% predict these values that are mixed up in here. Because remember, when I gave an introduction to KNN, I said that it's based on distance. So the closer these values are to each other, the harder it will be for you to like classify them. Okay. So if you do like scatter plots and your data targets are spread in a way that you can make predictions based on distance, you are free to use KNN to make your predictions. So this is our final output. So you can see it's almost similar to what we have up here. And these are the predicted values. So which means that our model is working as it should. So the next thing so we can do is, how do you choose the right K value? So you basically don't have to like choose the right K value. So what you can do is we can use a for loop, right, to find the best K value. And the best K value will be the K value that has the highest accuracy. So here we will have the scores. So the scores will be these accuracy scores that we have here. So we are creating just a list of scores. Then we will create a for loop. So for I in range 1 to 21, so we want to fit this model 21 times, changing this value that we have over here. We will have KNN dot KNN classifier being equal to number of neighbors, then I. Then we are going to append the scores there. Then we can plot the scores. So we are going to have plt.plot. So we are going to plot the range against the scores. So that's a line plot. Then our X label is the case, because that's the range that we have. And our Y label is the accuracy, which is the scores that we have over here. And if we run that, we can see this. So you can see if we use an accuracy score of the number, if we specify the number of neighbors to be equal to 1, we get an accuracy score of 100. And I believe that for us to like pick the best number of neighbors, we should stick to something like, so in between 15 and 17.5 we have 16. So if we want to a good model, we can stick to 16. So here I can change this from 6 to 16 number of neighbors, and if we run this, we get an accuracy score of 0.98. We run that, and if we do the plotting again, this is what we have. So you can see it has changed a little bit, but basically this doesn't affect how your model performs. So what you'll have to do is check this plot so that you are not using a value like 3. So for example, if we change this to 3, you can see for 3 our model had the lowest accuracy, which was 0.96, but on average the other values have an accuracy score above 0.98. So from point 8, 9, 11, 12, 13, so we have an accuracy score of above 9. And the aim will be to pick, so apart from this left hand side where we have 1, 2, and 3, where the accuracy score is dropping. So our aim will be to pick the next highest accuracy score from what we had when we had like one number of neighbor. Yeah, and basically that's all for this part on KNN. So you guys have any questions concerning KNN and how it works?
Hello, Joseph.
Yes,
There is this part that I didn't get properly on the correlation on
yes,
between the purple, blue, and are they purple or something?
yeah,
Blue and
this part here,
yellow dots in the plot.
yeah.
Could you maybe go back? Yes, yes, somewhere there. Yes. Could you
Yeah,
maybe
maybe
you can
I can explain using this plot, right?
sure.
So what I can do is I can add the correlation value here. So we'll have print. Okay, so then I'll select the two columns. So iris df. So correlation iris df. Then I'll select the petal length centimeters column and the petal width centimeters column. Then I can run that. So here you can see like I forgot to add the dot core part. Yep. And here you can see the kind of correlation we have. So the correlation between petal length and petal width is 0.96. And if we look at this scatter plot, so what does this mean? So correlation has a range of maybe -1 to 0 and 0 to 1. So if the correlation value here is high, so for example, this correlation value is at 0.96, so it's close to the maximum, which is at 1. So it means that these two values are highly correlated, and it basically means that when one increases, the other one also increases. So here you can see, for example, if we had a petal length of 2 centimeters, it means that basically the petal width will also be low. So we will expect that the petal width will we cannot like get a petal width of 1 in cases where we have a petal length of 2 centimeters. But if we increase this value to 5, we are expecting that our petal, so if we increase the petal length to 5 centimeters, we are expecting that the petal width will also increase to something around 1.5 centimeters. So that's basically what correlation means and how correlation works, right? So have you understood it? Like what I'm basically saying is when the petal length is increasing, the petal width is also increasing. Yeah. And
So
in all, that's not the case in each and every situation, as you can see here. So variable is each variable that we have in here has a different correlation value. Yeah. Yeah, you can proceed. You are saying something.
Yeah, what I actually was saying is, I
Yes.
wanted to get these yellows, the blues, and the purples.
Yeah.
I don't know whether they're black because either black or purples. So I wanted to get these because, for example, in the first scatter,
Yeah.
um, on the lower scatter, where we have in between one,
Mm-hmm.
kindly don't move it. Thank you. So between 1 and 2,
Mm-hmm.
where we have a petal length of maybe 1.9 or
Yeah.
8. There is that is the petal length. Then the
Yes.
petal width is around 0.48 or 49,
Yeah.
47, somewhere there, if I'm not wrong. Then we move to the blue ones. So these blue ones,
Yeah.
and there is a point where it said that they moved. Like the blues, we had some scatter there, so they moved down, kind of. So I wanted to understand this the correlation between these blues
Yeah.
and these yellows, and between these I call what this color, purple,
Yeah.
and the blues as well as the oranges. I mean, not the oranges, but the yellows. Yes, that's what is confusing me, kinda,
Like
because
you want to know what the purple color is and what the green color
representing
is. Okay.
representation. Yes.
Okay. So these are basically representing the class of what we are trying to predict. So I don't know if we can add the labels. Okay. So I think that basically works. And this should be equals to something like iris. Then we select the target names. Okay, so we'll get an error. So let's just stick to the ones and zeros. So here you can see we have is color scale, okay? And from, I can open this in a new tab. From this color scale, you can see we have three targets. So we have class 0, class 1, and class 2. So class 0 is the class which has the lowest values here, and you can see it's in purple, right? So anytime you see a purple value, you'll know that this belongs to class 0. And here we have class 1, which is, I think, in the blue part. So anytime you see a blue dot here, you'll know that this represents class 1. And up here we have the class yellow, which means that anytime you see a yellow value, it represents a class 2. And these classes are these colors, these are these flower species that we have up here. So for example, Setosa is class 0, so these are the Setosa flowers. Then Versicolor is class blue, so these are the Versicolor flowers. And Virginica is class 2, these are the Virginica flowers. So do you understand what the colors represent?
Now I get it 100%.
Yeah. So it's that simple. So using this scatter plot, we are trying to see where each flower species lies, right? And because we are using like distance to make predictions, then each color will be in a different location. So for example, if you were to compare, let me not use that. Let me try think of something else. So if you were to compare like if you are trying to like predict if an animal, so this is just an example situation. If an animal is an elephant or lion, so an elephant, giraffe, or lion. So what are the factors you will consider? So if we here the first factor we will consider is the height. So it means that elephants will be in here, in between, will be at this part here where their height is not that much, right? Then the lions, their height will be here because we know that they are the shortest as compared to the elephants and the giraffes. Then the height for the giraffes will be up here. So I believe that explains everything in a simpler way, right? Yeah. So any other question on what we've looked at in this notebook? Any other questions? Okay, so if you have